Good day, everyone, and welcome to another number theory problem solving session. We're getting our problems from the Nigerian Mathematics Olympiad, the first round. It's in your category. Okay, so let's go into this problem. So I told you to simplify something. So simplify this scary looking guy here and in a modular base. Okay, so let this guy be equal to x. Okay, so I'm going to apply Euler's totient function. It's kind of similar to Fermat's little theorem. And for those of you that are not familiar with it, I'll drop a link in the description where you can do more reading. So if we say let this be equal to x, so I want to find what x is congruent to. Basically, I want to find the value of x. Okay, so now we can look at 2020. 2020 is equal to 2 to the power of 2 times 5 times 101. So this is the prime factorization of this. And basically, we're going to apply Chinese-Shimada theorem again. And if you've watched some earlier videos in this series, I've spoken about Chinese-Shimada theorem about twice. And I've also dropped the link to Chinese-Shimada theorem for more reading about Chinese-Shimada theorem in the description of problem 40. Okay. So let's look at it. So we want to find what x is congruent to. Mode 2. Sorry. So I want to find what x is congruent to mode. Since it's 2020 squared, I want to find what x is congruent to mode 2 to the power of 4. What x is congruent to mode 5 to the power of 2. And what x is congruent to mode 101 to the power of 2. Okay. So now let's start with this. So now we have that the phi of 101, that's basically the number of integers relatively prime to 101 less than 101. This is equal to, sorry, the phi of 101 squared, because I mean we have 101 squared here. Okay, so this is equal to 101 squared into 1 minus 1 over 101. And quickly we can get this is equal to 101 times 100. And similarly, the phi of 5 squared is equal to 5 squared into 1 minus 1 over 5, which is equal to 5 times 4. Okay. So now let's look at what x is congruent to mode 5 squared and mode 101 squared. Okay. So so x is congruent to negative 2 to the power 2020 to the power of 5 mode 5 squared. Now I have x is congruent to, so this is same thing as negative 2 to the power of 5 times 4 times. So I'm just splitting this power of 2020. So times 505. Okay. Mode 5 squared. And this is equivalent to negative 2 to the power of 5 to the power of 4 to the power of 505. Mode 5 squared. And we're going to apply the Euler's totient function. It says that if two numbers are relatively prime, then a to the phi of b is congruent to 1 mode b. So it means x is congruent to, this guy here in the bracket is 1, so x is congruent to negative 1 mode 5 squared. And so we can keep that somewhere here. So I'll just keep that somewhere in the center here. So x congruent to negative 1 mode 5 squared. Okay. So now I want to find what x is congruent to mode 101 squared. Okay, so let's quickly do that. So I'll just erase this. And you know, like, the beauty of this is that this cannot really be computed with a calculator. I mean, the power is too big, and we just use maths, you know, to do it. And that's why maths is just beyond calculations. So let's go on. So let's find what x is congruent to mod 101 squared. So x is congruent to negative 2 to the power of 2020. I'm sure seeing 2020 here, people will be wishing that we are writing Olympiad in the year 1 AD. Okay, so this, want to find this residue mode 101 squared. So this is equivalent to x. So I'll put this negative. So I have 2 to the power 101 times 4 times 5 times 5 mode 101 squared. So I have x is congruent to negative 2 to the power 101 times 100 mode 101 squared. Now see that this power here is the 5, so I have x is congruent to negative 1 mode 101 squared. Okay, so it means x is congruent to negative 1 mode 101 squared. Now quickly, what can we get from here? Quickly, we can see that x plus 1, just put this, x plus 1 is congruent to, so we can combine, x plus 1 is congruent to 0 mode 5 squared, and x plus 1 is congruent to 0 mode 101 squared. And so this implies that x plus 1, so I'll just put, the board is getting filled up, so I'll just put it here. So x plus 1 is congruent to 0 mode 505 squared. Okay, so let's move on to the final bit. Okay, so I'll just erase this. Okay, so I have some space. So this implies that x plus 1 is equal to some 505 squared times k. Okay, so let's move on. Now we have that x is congruent to negative 2 to the power 2020 to the power of 5. So we want to find its mode 2 to the power of 4. So I was finding to each of the prime power factorization squared. So we want to find this to the power of mode 2 to the power of 2 all squared. So mode 2 to the power of 4. And we see that this power of 2 here is very big. So x is actually congruent to 0 because 2 to the power of 4 will divide this guy here. So x is congruent to 0 mode 2 to the power of 4. Okay. So it means we can put what x is. So this implies that 505 squared k minus 1 is congruent to 0 mode 2 to the power of 4. Okay, and then we have so 505 is congruent to 9 mode 16. So you can quickly check that 505 is same thing as 496 plus 9 all squared k minus 1. And so we can see that 496 16 divides it, so we have 9 squared, which is 81 k minus 1 or 2 to the power of 4. And we see that 80 is divisible by 16, so what we have k is congruent to 1 mode 2 to the power of 4. Okay, so let me just erase some things here. Okay, so we have that we can express our k in as a multiple of 2 to the power of 4. So we can say k is equal to some 2 to the power of 4a plus 1. Okay, so now it means our x, which is equal to 505 squared k minus 1. So x equals to 505 squared k minus 1 is equal to 505 squared into 2 to the power of 4a plus 1 minus 1. And this is equal to 505 squared times 2 to the power of 4, which is same as 4 squared. So I'll just put 4 squared here. A plus 505 squared minus 1. So I'll just erase this bit here. So you can always pause the video to look at what I'm erasing to make sure you understand everything, follow all the processes, and always feel free to share your ideas. I mean, someone might have an easier solution. So I have x is equal to, so we see that 2 squared times 5 times 101 gives 2020 squared, 2020 squared. So x is equal to 2020 squared times some integer a plus 505 squared minus 1. So it implies that x is congruent to, so when we're checking the congruency 2020 squared, x is congruent to 505 squared minus 1 mod 2020 squared. Okay, so we have our answer, option A. And that'll be all for this video. So don't forget to share, comment, like, subscribe, and see you guys in the next video. Till then, keep solving maths. Yeah. Goodbye, guys.